Today I'm joined by Dr. Janet Bastiman, Chief Data Scientist at Napier AI. In this episode, we discuss how AI is used in financial crime and compliance, what explainability looks like in practice, and how organizations can balance automation with human oversight. Hi, Janet.
Hi.
Thank you so much for giving us your time today. Let's set the scene a little bit. How's the use of AI in financial crime and AML evolved over the last couple of years?
So it's one of those things that AI has just become pervasive in business and industry. And when it first came out, a lot of financial institutions knew they wanted to use it, but not entirely how. And we saw a lot of projects where they were just putting AI systems in place without much thought as to what the use cases were or how it was really going to help. And to some extent, with the advent of generative AI, large language models and chatbots, we're still seeing that we're just going to add this layer of AI without really thinking about what's under the hood. However, the institutions that are being more mature with how they're doing it and more successful are looking at where their pain points are, where their problems are, and applying the right types of AI in the right types of areas. So, for example, language models are very good at generating text, but not necessarily at the precision of numerical information that you might need for AML investigations. So for those, you'd need different types of AI. So the places that are really getting this right are looking at where they need to make a difference and apply AI in those places and augment their human experts in a way that makes them really efficient in their jobs. And I think that's the biggest change, that the companies now understand how they can best use these systems.
And when we talk about different types of AI, obviously it sounds ridiculous to say this so quickly, but we all use AI in our everyday lives now. I suppose we did pre-LLMs, but it wasn't what everyone kind of colloquially thinks of as AI now. But we all use LLMs like ChatGPT. When you're talking about different types of AI at that enterprise level, is it smarter LLMs? Are they different types in terms of machine learning? Can you break down the differences from sort of everyday user to enterprise need?
Yeah, absolutely. And I think, say, LLMs have become synonymous with AI, and that's what most people think of when you say AI. They do think of ChatGPT or some of the image generator models that can adjust photographs or create pictures for them. And I think that's just because they're very easy use cases for most of the public. What we've been using for years that people don't necessarily realize is AI are things like recommender systems. So if you're on Netflix or other streaming services and it's like, you might like X, a lot of that is sort of machine learning models that are based on how you interact with the system and feedback. And from a financial crime point of view, if you're looking at doing, for example, screening or individual tasks and cases, having models in the background that learn how you interact with different pieces of data so that they can then recommend similar things to you and similar ways of suggesting a workflow or dealing is a very different type of model under the hood than a language model. Because in simple terms, the large language models are a supercharged version of predictive text on your phone, but rather than just predicting the next word, they're predicting paragraphs or whole text based on the prompts and inputs. But it's a very similar thing. It's statistical. It's pulling information from the data that it's learned on, that it has access to, but there's still that statistical level under the hood. So if you're looking at, for example, classification problems where you want to maybe do review, discount, or, approve or not approve, say, a loan or something like that, you'd need a different model that can look at all of the features of the data, maybe some of the historical data, and put that together in a way that can be explained and you can sort of tick off the different metrics. When we look at, and I'm sure plenty of people listening to this will have heard of agentic AI. Some agentic AI is basically lots of different AI models sort of in a trench coat, sort of stacked on top of each other. So it's not one model, it's sort of a workflow. And then you can get true agents where they say, as clues in the name, they have agency, they can go and do things themselves, whether that's edit code, whether that's have authority to review cases and do the whole pipeline of gathering the data, documenting it, and then making a final decision. So there's all of these different kinds of things, and not every problem needs a language model in the same way that not every DIY task in your house needs a power drill. It's definitely the right tool for the job.
You mentioned something you can explain, or in a way you can explain it. Explainability is a term that's kind of thrown around in compliance quite a bit, but we also see AI as, particularly LLMs or kind of statistical based models, as kind of a black box. You don't really know how it's achieving that particular answer, apart from the scale of how the system works. At a one-to-one level, me interacting with ChatGPT, I'm the human in the loop. I can review the answer, I can make sure it is the correct answer, and then move on. But once you get to the scale of enterprise workflows, where you're dealing with lots and lots of data that a human couldn't possibly review, that explainability element must become a lot more important. But what does that kind of look like on a day-to-day basis?
So just unpicking sort of how you asked that question, I think that as an individual, you're reviewing the output is critical, and that's the whole point of human in the loop. And a lot of the legislation we're seeing is making sure that regardless of how you get an answer, that it's correctly reviewed. So if you had humans generating results, most institutions have a process where there's a second or third line that will review that and double check the data. And it's really important that when we're using AI, we follow similar practices. There have been plenty of news reports where AI has got the answer wrong. I really hate the word hallucination because it feels like it's a fluffy thing you don't need to worry about.
It's too anthropomorphized.
Absolutely. If you failed your driving test, you didn't hallucinate all of the bits you got wrong. You got them wrong. And I think it's really important that we remember that it's an error and that these models are prone to error. So you have to double check their work. Just as if you get the brightest graduates from the best universities and give them a problem, you'd still want to double check their work because they don't have the experience and the knowledge. And as individuals, we do that to varying extents depending on the stakes of the problem we're setting. So if we're just asking ChatGPT to give us an itinerary for a tour around Belfast, say, then the worst that might happen is you might turn up to a museum that's closed on that day, or it's all public data and it's not a big thing. But when we look at financial crime, if a language model gives the wrong answer, it can have quite big, devastating repercussions. So that level of understanding and explanation is crucial. So even at an enterprise level, having those processes in place to verify outputs is critical. AI developers, there's a lot of things that people in my industry should be and to some extent are doing in order to help that. When you're looking at go back to the classification model. So if you're trying to reduce false positives and you want a review discount, you don't just want that computer says review, computer says discount. You want to know what the confidence is, what are the features in the data that led it to that decision, because that's what you'd ask of a human. You wouldn't just accept coming up and saying, yeah, you can ignore that, it's fine. You'd want to know why so that you can put that in your report. So we need to engineer these models to do the same thing. And particularly where it's referring to data, having those links back to the original data and not just a reference that could have been completely made up, but a link back so that someone can just double check that, yes, that transaction occurred and that's something that we're concerned about. There was this additional case. There was this adverse media we need to take into account. So having all of that in a way that's accessible to the end user. And I think that's why this term's been bandied around a lot, is that initially explainability was so data scientists like me could understand the accuracy measures of the models and make sure that we were choosing the right features and things like that. But for a non-data scientist end user, it needs to be in a language that they can understand and trust rather than just all of these numeric things.
I suppose as it evolves, that balance between automation and humans in the loop, although it always probably need to be there, will shift. You've got now organizations using agents to review other agents' output and things like that. So we've always got this push and pull between the risk of automating too much and the risk of too much human in the loop. And that's more, I suppose, for organizations, a concern about the risk of putting in too much resource, is it? What are the risks of kind of both of those ends of the spectrum?
So absolutely, there's so many things going on in the world of financial crime and compliance that to cover everything needs a large amount of resource. We're not at a point, even with the amount of automation we've got, absolutely everything can be investigated as thoroughly as everyone would want. So it's going to be sort of like a risk-based balance. Where things are lower risk, they can be automated quite easily, and where things are higher risk, you do want to have a more detailed investigation. So having systems that allow your experienced humans to do the more complicated stuff, sort of the long tail, as we'd say, that's really important. But they can't have the time to do that if they're being overwhelmed by false positives or really simple situations. So that's sort of the first step. And it's interesting that you mentioned sort of agents double checking agents, and it's that old sort of, who watches the watchers. So you need to have the trust that each of these parts of the system are doing their job correctly. And for a human workforce, you have retraining, you'd have maybe some sample checking just to make sure that they're doing their jobs correctly. And we need the same thing from an AI ops point of view, just to make sure that the models are still working correctly, regardless of the type of model it is, particularly in financial crime, because the typologies that we see today are different to the typologies of a few years ago. So having something that's really good that was created a few years ago is not necessarily going to be good now. So you've got to have those constant checks. And having a system that checks that also has to have knowledge of what it's looking for. So you need to have this almost continual review process and making sure that you're looking at the right sort of checks and balances. Because one of the things that I think a lot of people don't necessarily appreciate is when you're looking at accuracy measures in models, you've got to be very careful about what you set as your measure, because models can be overfit and therefore not perform well in real world, but are really, really good on your test data. Or they could end up being a little bit too narrow and missing lots of things that you really desperately need to pick up, and everything in between. So understanding not only what they're testing, but having those reports in a way that humans can understand and check those, which means maintaining the ability and experience of at least some of your human workforce alongside monitoring your AI sort of augmented workforce.
And I wonder, when you talk about sort of lots of agents or lots of LLMs or lots of AI systems interacting with each other, it's one thing to be the human in the loop at some stage or at the end of the loop, checking that the answer is correct or the process is correct. But when you've got so many different systems, so many different parts of the system or workflow, you've then got the financial services, you've got liability and responsibility and things that may need to be evidenced or looked back on 2 years' time, a year's time, to say, this is why we made this decision, and it was this part of the system, and we need to address this now. How do you manage that? Is each part of the system keeping its own log? Can you talk a little bit sort of technically to how that works?
One of the things you have with models is that they're responsive to all of the data that's been used to train them. So when you first implement a system, you should do an audit showing of this set of data in, this is how we got data out. So in a classification, these are the names we discounted, or for a language model, given this process, this is the explanation text that came out, and have all of that scored and audited. And then once you're into production, you need to be monitoring the models. You need to know what version is running, if it's been retrained on data, what data it's been retrained on, how the different accuracy measure changed every time it retrained, and different models will take that into account differently. So, for example, you can have a regression model that's looking for deviations against history that's just constantly updating its output based on the data, or a classification model where you train it and it doesn't immediately update itself unless you tell it to look back at the data and what it's got right and what it's got wrong. So different models need to be audited in different ways. That then all needs to be combined so that when you've got that end to end, you can say, for this situation at this specific date and time with this input data, it went through all of these models. You've got tables in the background that say, okay, at that timestamp, this was the model ID, this was the data it was trained on, this was everything that came before, and all the way through to the end, and then you can create that audit report. That's really important, because if you do get a rogue model, then you need to be able to go, okay, what else was impacted by this model? So, for example, if someone, let's say model poisoning is something that's a thing, and let's say it wasn't even nefarious. Let's say it was just a user who was putting data into the system incorrectly. And then that then went on to retrain a model where the data was wrong. You'd want to be able to isolate that quickly, roll that model back or retrain it into something else, and also see what was affected. So that whole pipeline of audit is really important, not just the end-to-end, but each individual model, so that you can isolate. In much the same way, again, I'll go back to like that human process. You've got the workflow. If you've got someone in that workflow that's not very good at their job and is meaning that things downstream from them are impacted, either people aren't getting the right data and therefore making the wrong decisions, or things aren't being filed correctly, you would retrain that person or replace them. And we need to take the same approach with the models. So having that information recorded is critical, and recording it for the right length of time. As you indicated, some of these timescales can be, when things go to legal systems, can be years after the event. So having that stored in a way that's accessible at the right time and is still clear, even though everything else has moved on, is very important. But it can be done. It's just, say, it's technical and it's back end and it's fiddly, but it's part of the compliance process.
And when you're looking at accuracy, I suppose you're not specifically just looking at accuracy when you're thinking about humans continually training models with the answers they're giving, or the reviews that they're giving the answers. It's also a case of proportionality, fairness, discrimination, not just are we getting the right answer, but are we being biased against certain types of people, things like that. How do you balance both, or how does a model balance both?
That's a great question, and it's difficult because it's something that you have to take into account when you're developing the models. So going back to ChatGPT, it's very Western view, because it's been developed by Western countries and it's been trained on basically English language. So the way that it responds to things is very based on Western culture, and that's not necessarily appropriate for different countries. And we see the same sorts of things in finance, where the way in which people interact with money and how they like to do things in the UK is, let's say, very different from a country in Africa, where it's like there's a different mindset and approach and how they've dealt with money. So we need to take that into account when we're building models. Is what are they for, and what are the guardrails that we need to put in place to make sure that they are only used in the right way. That requires a lot of upfront thinking, and it's one of the reasons why it's really important to have good thought diversity and experience in the teams building these models. And particularly in the finance industry, we've had history of people going into data-based roles that are all from very similar universities with very similar educational backgrounds and upbringing, and you tend to get more of a groupthink and agreement like that. Whereas even in the UK, having people from a wide disparate backgrounds is really important, because a lot of the people who are some of the poorest in our society, their financial pattern overlaps with money laundering patterns quite considerably. So if you think of people that have got like multiple 0 hours contracts, they don't have a regular salary, money in is quickly money out, it's constantly being transferred around, they're trying to balance their lives. That triggers so many of the rules about accounts just used for pass through of funds. So having someone that recognizes that it's a valid lifestyle, that there are many people in this country that live like that, and that's not necessarily money laundering, will stop a model discriminating against those sorts of people. And similarly, if you don't have enough representative data, let's say in your data set you only had one person in Reading, for example, that's near where I live, and that one person had a flag against them and was high risk, the model might learn that the risk is associated with location and not necessarily all of the other features. So when you're building and testing, it's really important that you take all of that into account and validate that it's not biased. And you may need to augment your data set with good quality synthetic data to make sure that the models don't learn the features that you don't want them to. What's even safer is to drop some of those features depending on what the model's doing and saying, okay, well, if age and gender and location are not valid in whether someone's a risk for a certain event, then for that model, I won't let the model even look at that data. It has no access to it. So it has to draw conclusions from something else. And that's all part of the R&D and testing process, and having that sort of ethical mindset make sure that when you build the models, you don't end up with some of the. There's been plenty of high-profile, embarrassing mistakes where people haven't thought of these things, and then as soon as it's gone live, it's like this model's biased against hiring women, or this model is biased against who can be released from prison early, and all of those sorts of things are because people didn't do their due diligence and proper practices up front.
Can you take that a little bit further and explain what synthetic data is? Because I feel like a lot of people have heard that term, probably understand what it is to an extent, but how it's generated, I think, is a little muddier.
Yes. So you have, obviously, there's the real data, which has data privacy issues. So you don't necessarily want to be using sort of fully real data for all use cases, because some models will take that on board and could potentially leak that data out depending on how they're interacted with. So the next thing you would do is maybe encrypt or obfuscate certain parts of the data. The problem with that is, while you could then have a model that could look at certain patterns, it's then not very good at recognizing realistic data. So that's great if you want to have a wider system that doesn't have real names and addresses and phone numbers and all of that in, so that you can display those and then run models for, let's say, transactions. But even then, you've got to be really careful, because if you're looking at, let's say, big unusual transactions, so let's say you're looking at business data and someone's bought a football club, you're going to have to change a lot of that data and encrypt a lot of that data before it's not obvious what that transaction was. I mean, it's a really big example, but there's things like that, or particular postcodes where sort of house purchase and things. You want to make sure that all of that's hidden. So the way you get around that is to look at your sample data set and go, okay, I'm not going to use any of the real data, but I'm going to take the patterns and the extremes of my real data set and create a generic data set that maybe covers the same time period. It has the same distribution of accounts with the same distribution of types of transactions to similar merchants, but each of those real things are completely replaced by sort of algorithms that create that distribution. And I mean, it's one of the things that you can use generative AI for, is like, given this pattern, create this other pattern and then check it. So the synthetic data is, in essence, as real as you can get without getting real data copy, so that we can train and run these models safely. And that's always a great starting point, because then you can make sure that you've got within that sample data set that you've created artificially, you can say, actually, I want to have an even distribution of ages, an even distribution of locations, and it gets over that imbalance that you would get in real data. You train the model on the synthetic set, do all of your accuracy testing on that, and then you only give it real data when you're into the final testing steps.
Let's bring it slightly away from the technical, more towards the kind of board level. Where are companies seeing the biggest benefits in moving from, let's say, what they had? How far are we into AI? 3 years? Say 3 years ago into this wave of AI, I should say. From 3 years ago to now, having implemented systems for risk analysis like Napier AI.
Yeah. So I think one of the biggest problems that most companies had was They might have had that board drive to adopt AI, but their systems and processes and data were not in the right place. I'm still seeing companies where everything's very siloed, and it's quite a big project to get all of that data in one place so that the AI can make use of it. Or they're just trying to replicate quite a long-winded human process step by step without really understanding the essence of what they're trying to achieve, that could be done more effectively and efficiently using not just AI, but different, just general sort of automation, and then thinking beyond that, okay, well, if we had more time, what can we do? And we're now at that point where the companies that were those adopters, say 3-4 years ago, they've got their data in a good place. They really understand their workflow and processes. They've implemented AI to solve their pain points, and they're now really looking at what else they can do. And they're pushing beyond that initial we're overwhelmed with signals to we've got our signals under control, and we're now pushing out into the things that we would never be able to look at before because we didn't have time. And that's down to looking at, say, the right model at the right place, the data's in the right place. They've got trained staff that know how to check the outputs quickly and move on. And then the new projects are very much looking at the more complex use cases and how different AI models can help them with those. And that's a really exciting place to be.
You mentioned some of the challenges or the pitfalls of deploying AI there at early stage. I wonder if you can give some advice to boards on the questions they should be asking if perhaps they're not as far along as that. Their tech teams are telling them we're implementing AI for risk, for AML. What questions should they be asking?
I think the first question that anyone should ask is like, are we ready? And that's quite a broad question, which I'll break down a little bit. So very much do we know what the problem is that we're trying to solve? Have we got everything in place to solve that problem using technology? So is all the data connected up? Do we need to create APIs to join data together? Do we have the right resources? Does this need to be stored on our own premises? Are we happy for this to go into the cloud? Where does that need to go? What are our legal obligations regarding our data? How can we then work within those requirements to solve the problem that we've defined, and what solutions are then available? So one of the things that I have seen time and time again is we're falling behind, we need to add some AI, and there's very expensive rollout projects where everyone in the company gets a local language model, chatbot, that might even be installed in-house. It's given access to environments, but it's not necessarily been set up in a way that makes sense for that company. So just as not everyone in the company has access to every document, you wouldn't want your L1 compliance officer having access to all of the HR documentation, for example. If you roll out AI and don't put the right guardrails in place or understand why you're doing it, then you can end up with all sorts of data leakage problems, potentially as people are interacting, depending again on how it's been rolled out. Then you might end up with people putting the wrong information back, so elsewhere in the business gets impacted. So what they need to be thinking about is there a valid project to use this? What are the use cases? Therefore, what boundaries need to be put in place so that we can move forward in a quick but safe way? And I think those are the questions that don't often get asked or answered properly when these projects start.
We are running out of time, but I will ask you one more question before I let you go. What are you most excited about this year, personally, professionally?
So professionally, I'm pretty excited about some of the research that my team and I have been doing with the FCA as part of the Supercharged Sandbox, where we're really looking at completely novel ways of detecting some complex typologies. So one of the issues we have is that most financial institutions, they can only see their own data. So where you have money laundering, where the money's injected upstream and potentially taken out downstream, finding those cycles and everything else that's in their data set is quite difficult, but that's an important part of the puzzle. So we've been looking at inspiration from some quite diverse areas of physics to basically look at financial data through a different lens and see if we can detect those ripples through the data in a way that we can then say, actually, this is potentially a complex network typology that you just can't see the start and end of. And that's something really exciting. I guess sort of the other thing is just the push of education. I think it's wonderful that more and more people are using AI. And I think what I would hope for this year is that maturity of understanding of what it is and making sure that people become comfortable with what it isn't and what it doesn't do. And I think if we can get to the end of the year with both of those things in place, I'll be very happy.
Well, thank you so much for your time, Dr. Janet Bastiman from Napier AI. We'll speak to you soon.
Thank you.